Hey guys, it's Team PO5B on the High Performance Multi-Stream Camera Project, and we are Chandon, Harry, Kyle, and Judah, and you guys tasked us to develop a replacement for the RasPyCam JPEG utility compatible with the RPyCam web interface frontend that could replicate the functionality using V4L2 instead of MMAL while remaining fully open source. The Raspberry Pi is Britain's best-selling single-board computer. They can be used for many things, including when the camera is installed as a low-cost home security device. The RPyCam web interface was a software package that made this easy. You got live preview, video recording, still image capture, and motion detection, all at the same time, all manageable from one single tidy user interface. And then it stopped working. With the latest version of the Raspberry Pi operating system, the backend utility, RasPyCam JPEG, was no longer compatible with the latest OS. The latest OS completely replaced the camera API being used by it. All of that value lost. I mean, there were new camera utilities that shipped with the new OS, but nothing as convenient and valuable to the wider Raspberry Pi community as the RPyCam web interface. We're happy to say we've managed to deliver on the 4 core functionalities you guys requested for us during our scope meeting. We've got the resizable preview working. You can adjust the size, the quality, and the frame rate using the front end or through direct pipe command. We've actually extended the pipe command so that it takes an optional extra parameter for the height, so that you can now manually set the height with the pipe command if you want, instead of what it usually does, where the height automatically gets set to 16:9 aspect ratio of the width. And in addition to that, we've got the still capture working both through the front end button and the pipe command. We've added a new pipe command that will temporarily switch the camera to the highest resolution, then take the photo and then switch back. Or if you like, you can manually change the stream size and the camera resolution too, so you don't incur the performance hit that normally comes from switching configurations. Bear in mind though, the front end settings will only change the stream size, not the sensor mode resolution. If you want to change the sensor mode resolution, we've got a new pipe command that will let you do that too. We've got the video recording working, we've got the motion detection working. It doesn't work quite in the same way as RasPyCam JPEG. Motion detection now uses mean square error of pixel differences rather than motion vectors, but it works. You'll see it all in the demo. We made sure that all 4 of the core functionalities can work at the same time. We've tested on the Pi 4, on the Pi 5 with a 64 megapixel owl-side RGCam with the V2 camera, and our system uses only open source libraries, though, as you may know, with regards to the open source requirement right now, we're still waiting on the university for permission before we can actually upload anything onto a public repo, because right now the university owns all our code, and our contract actually says we're not allowed to publish any results on our project without explicit written permission from our university supervisor. When that's going to happen, I suspect that's tied to the marking timeline, but we'll see. We're also happy to say we've managed to complete the extension task with multiple cameras. We've actually extended the pipe command format so you can now send commands to multiple cameras at once and target specific cameras to send commands to. And we've implemented new pipe commands for taking a stitched image. The front end doesn't have a button for this for obvious reasons, but you can see stitched previews on the front end. The video streams of both cameras will need to be the same height for it to work. And if they are, then the stitching will be automatically applied as long as the previews haven't been turned off. For still images, they don't need to be the same dimensions to stitch. We've made it so that it'll just pad out the difference with black pixels if one of them is smaller. We've also restored functionality to let you select white balance mode, color gains, brightness, saturation, contrast, all that jazz. Unfortunately, we couldn't implement rotation because turns out V4L2 doesn't have that facility. I know another group mentioned doing rotation. We actually investigated how they did it. We found that what they actually did, they used the flip functionality to do it, which is why they can't actually do anything other than 180-degree rotation. That 180-degree rotation is just turning on horizontal and vertical flip at the same time. Meanwhile, our team just implemented the flip as flip because that's its own feature on RasPyCam JPEG. We've also managed to do a version of the annotations that supports timestamps. No background or color changes, unfortunately, just the text. You'll get to see that all in the demo as well. So how we implemented the streams, we ended up using the main stream for still image capture, the low-res stream for videos, the preview and the raw stream, the low-res stream for videos and the preview, and the raw stream for motion. In the end, we couldn't quite crack reverse engineering Beta to JPEG. We planned to use the raw stream for stills. It didn't work out. What we managed was very slow, plus we found we can't actually use the low-res stream with a 64 megapixel camera at maximum resolution. Turns out the 64 megapixel camera just doesn't like running more than one stream at once. You can't start it with more than one stream without running the memory issues and crashing. So it's got to be on the main stream, and this is what we ended up with. As we mentioned before, we've used only open source libraries, and only 2 of them, which are PyCamera 2 and OpenCV. As far as we're aware, PyCamera 2 comes with the latest versions of the Pi OS. OpenCV doesn't. What we've done is we have an installer script that will grab OpenCV and install it when you run it. And if you ever feel like poking around inside our stuff, this is what the file structure of our program looks like. You can think of it in terms of model view controller. If you run it without the interface, then there's going to be no front-end view. You'll start it just by calling main.py, and then it will make 4 threads, one for the preview, one for motion detection, one that reads the command pipe, and the original thread, which is used both to execute commands as well as take still images. When video recording starts, the encoder will also start running in its own thread. You can launch the main.py with file path arguments to a config file of the same format that's used by the original RasPyM JPEG. This file is what is listed under the model section as the base config file. If you're starting it with the front end, you'll be wanting to use the start script that we made. It'll launch with the RasPyM JPEG config file that RPyCam web interface installs in the etc. folder. Now then, instead of talking more about it, you guys probably want to see it in action, so here's the good bit. Harry from our team is going to show you guys the demo.
Hello guys, hello Kian. So this is our demo for our app RasPyCam. So in this demo, I will show you how I walk you through how to install the app and how to make it compatible with using multiple cameras and what is the functionality of our app. So basically, let's begin. So to start to install is as simple as running. When you clone our repo, we will have a install script. It is as simple as running sudo install shell. We require sudo because the RPyCam interface also requires sudo to install the script. That's why we have to use sudo, so we can call the other app with sudo. And it will promise, we will ask if we wish to install the front end as well. So in this case, we do, yes. It will cloning the front end interface. It will patch all the old code of like the install script, the install script, the start and stop script, and replace with our batch code, so it will come compatible. So and it will launch the install script of the old front end as usual. Yep. Basically, with our app, it will copy our whole app Python script into the location of, I will show you right now. If you look into, I clear my screen. If you look into opt, vc, and bin, you can see our app here, RasPyCam. But as in the other hand, if you go to /usr and then bin, and then you can see RasPyM JPEG. And you can see here we also have the RasPyM JPEG so-called binary. It's actually just assembling to a bash shell into our app. But for now, we will look at how to run the app later. But for now, we will look at the app in action in the front end. So as you can see, we just run the install.shell, and the app is already installed with the front end, and you can see it here. Yep. So as I have in here a camera, it's working. You can see I'm playing a videos on the screen, and the camera is pointing over there. As you can see here, we have some of the feature. We have implemented many of these features. You can have a look at our documentation on see which feature we have implemented, but most of them is already in there. For example, you can see it's a little bit small. You can put it in like 124, press OK, it's a bit bigger, and the quality is bad because by default they said it's at 10. So let's change this to 100. You can see it's really bad, and when I press OK, the quality is better for the preview. So first of all, we can record an image, obviously. Well, it changed. We can record a video as well. Let's see the record video. We will have a look at them later. For now, all the functionality here, these 4 buttons all work except for time lapse. Time lapse didn't work when we look at the app, so we have no idea how it worked before, and we have no idea how to re-implement it. So for now, time lapse doesn't work. However, all the button is working. We can stop the camera. As you can see, the video is still playing, but I stop the camera and I can start it again. Yep, just like that. And also we can change things, like we can change the video FPS to be 30 FPS when we record the video. We can say OK, and it took a little bit of time to apply the setting, and it's already there. So we record a video and then we stop. We can see all the video here. As you can see, the recording is 30 fps. The preview might be choppy, but the video here is 30 fps. And also we have the picture taken. And also we have implement no motion detection, as you can see here. One thing with motion detection is depends on which resolution you add. Right now I'm at 1080p. You might want to set the threshold a little bit different. For me, as I noticed, for 1080p I'm working with around 2350 to around 2500 to 2700. It depends on how much background noise you have, because sometimes it pick up background noise and it check it as motion. But for my thing, I don't have that much background noise. I have a bit, but then it's not. So I said my threshold is 23, but you might have to play around to make it work. So let me see, I can motion detect and start. Okay, maybe that is a bit too low. I would say that 2400, it pick up some background noise, so it start recording as soon as I put it on. Let's see. Okay, so you can see like at the video stop, the motion detection is stopped, and as soon as I play the video, it record the video, and then I stop the video. It will take a while if you keep recording after the motion stop, but after a while it's gonna cut around 10 seconds, as you can see over there. And I can stop the motion detection. You can see download image over here, and you can see as soon as the video play, it's gonna play, but I'm gonna stop it, and after like around 5 seconds, it's gonna delay around 5 seconds to stop the video. Yep, that's for now. And you can see, you can change these number. Yes, you can see it's a flashbang because brightness is 100. I can put it at like 75. Yep, it's light. I can put it at 50 to be normal. Contrast, I can put it at like 75. The contrast is horrible. Something like that. Many of these features we have implemented already, and it works very well. One of our most impressive feature is we support multiple cameras, and to implement multiple camera but also when you're working with front end, you can do like this. But on the other hand, if you want to have an API that send the working with our backend only, you don't want to use the front end, you want to use it as a part of code, you can send a command into the pipe, and I will demo right here. So I will paste this command in, and this command basically just echo IM is this command is taking image to this pipe because it's running along with the web app. So I'm just setting the pipe as www data as the user that running the web app and the user who's currently control the pipe. So we don't have any permission conflict. I will send that, and as you can see in this picture here, you can see that we have that picture. Oh no, this is a video. We have that picture, and maybe I will make. We can also change this text as like pipe picture, and I can get okay, and you can see it's changed to pipe picture in the corner. We can also format all the date and time, but I will send the pipe command again, and you can see and also we have another function that take a full resolution image. So I will say this is the function that is different from the older RasPyCam JPEG because they don't have the function to take the picture in full resolution. I will send a command to the pipe right now, and you can see from the front end that we have. It took a little bit of time to take the full resolution picture, I believe. But this is the pipe picture using IM command. If I reload it a bit, this one will show up, and you can see it's much bigger resolution, and you can see like the pipe command is in the corner now, and you can clearly see the title is in much better resolution than other picture. You can see right here. Okay, so for now we are only covering the functionality that we have with the old RasPyCam JPEG. Now I will look into dual camera. So it is as easy as plug in a new camera and reboot. One of the things I do here is I have an RasPyCam, which is not a normal Pi camera, so I might need to change the config file. I have a backup here, so I just paste this command in. Okay, to use the two camera, is it as easy as plug in another camera and reboot? So after I reboot the Pi, I can just SSH into it. And as you can see on the front end, we already have the two camera pickup and we have a stitch preview ready. So we can change some setting and it's going to be applied to the cameras. So 720 and 100 quality. As you can see here, yes, it applied and it look great. So the functionality is still working, and as well as the stop camera, of course, now it's no longer running, and we can start again. Which you can see my hand is waving. Yes, but as you can see here, there's no button for recording video or take a picture for two camera, because if I press this record image, it's gonna take a picture for one camera, the first camera. So what I do is we need to send the pipe command again. So we'll go in here and the format of the pipe is the same, except now the command is im plus im. Like this is the command, the new command. Before we have im and now we have im plus im, which is take picture from two cameras. We will send that in, and as soon as we do that, you can see a new picture pop up here, which with of course with the text, and then the picture of the thumbnail is also stitched. The picture is also stitched together, and this is we have two camera with two different resolution. That is what happening. But yeah, if you read into our documentary, you will find out more command and more how to set up the config file. You can run the app with our install script. You can run the backend as simple as RasPyCam JPEG, just like the old app, basically just like the old app, and it will call our app, and you can pass in the config file with using this flag, and you can the path to config, and then if you pass into one path config, it will apply to one camera or the first camera. The second camera will initialize with default hard-coded config, but you can also pass in another path to config 2, and it will apply the config to two camera. And of course, you will have different pipe. You will run as in a different pipe, and then you will run a different user, which of course you can use. You can send the pipe command easier. If you read the doc, there will be more instruction or more capability. I can only show you so much here. You can see for yourself in our documentary on what function we have implemented, and also on how to edit the config file, how to run it. And that's it for our demo for today. And I'm glad you're happy with it.
Great, thank you, Harry. Now for testing our applications, we conducted manual testing, just like what Harry did in his demo. Each time new features are implemented, we always first test to ensure that our application's functionalities are working well with the web interface, specifically the RasPyCam web interface. We have also written unit test cases to test all functions that we wrote in our project, and for now, we have an 81% coverage. The library we used is unit test, which is a built-in Python testing framework that allows us to write and run automatic tests. So this test will run automatically whenever we push a change to the repository, and then a coverage report will be generated, which we'll talk more about on the next slide. Besides that, we also have implemented performance tests because our project aims to build a high-performance multi-stream camera system. We have used the PyTest performance library for our performance tests. An example of such test would be image stitching at different resolutions, where the test configures two cameras to specific resolutions. It stops the cameras, rebuilds their configurations, and restarts them to apply the new settings. Tests then captures and stitches the image from the cameras measuring the time taken to complete the process. The test will ensure that the stitching process completes within the acceptable duration, and for this test we set it as less than 6 seconds. And of course, these tests are running automatically instead of manually. So this is only one of the many examples we have. We also implemented many performance tests for the recording feature, which can be found in our repo. We've implemented a continuous integration workflow to maintain the quality and the compatibility of our code. The process begins with formatting and linting, ensures that all code follows the same rigorous standard. We then set up a job to automatically run all the unit and performance tests on ARM64 device. Next, we created a job to check if there's any ARM-based Pi devices online, and if there are, the program would also be tested on those. This helped ensure cross-compatibility was always achieved. Finally, whenever a change is made to a branch with an open request, a coverage report is generated and a comment is automatically made in the pull request, outlining the overall coverage percentage and information on the individual files in the program. Finally, we also made a continuous deployment workflow, and this includes one step, which is to create a draft release with all the code currently in the main branch. This release is created with automatically generated changelogs to help speed along the process of deploying a new major change. This marks the end of our presentation. If you'd like to try our program in action, check out our repository. Link is also in the description. Thank you so much for listening.